Assalamu alaikum warahmatullahi wabarakatuh. In this video, we will solve examples of practice set 1.2, example number 1 to 5 from the chapter Similarity. First example, given below are some triangles and lengths of line segments are given. You have to identify in which figure ray PM is bisector of angle QPR. So in that first example, here in triangle QPR, the length of the sides line segments are given. So here you have to decide whether ray PM is bisector of angle QPR. So here you have to in triangle QPR or PRQ, in triangle PQR, the ratio QP upon PR, QP upon PR is equal to QP 7 upon 3 and QM upon MR, QM upon MR is equal to 3.5, QM is 3.5 and MR is 1.5, 3.5 upon 1.5. Now if you observe the ratio, here 7 upon 3 and 3.5 upon 1.5. If we give a common multiple to this ratio, QM upon MR, common multiple, the value of the ratio doesn't change. So here we will give common multiple as 3.5 into 2 divided by 1.5 into 2. Giving 2 as common multiple, the value of ratio doesn't change. So 3.5 into 2 is 7 and 1.5 into 2 is 3. Now the ratio QP upon PR is 7.3 as well as QM upon MR is also 7.3. So therefore ratio in triangle PQR, ratio QP upon PR is equal to QM upon MR. Since the ratio is equal, so hereby converse of angle bisector theorem. By converse of angle bisector theorem, ray PM is bisector of angle QPR. That ray PM is bisector of angle QPR. Question number first, second example. Here in this triangle PQR, PR is 7, PQ is 10, RM is 6 and MQ is 8. You have to prove that whether this ray PM is bisector of angle QPR. So in triangle PQR and triangle PQR, just let us see the ratio PR upon PQ, PR upon PQ is equal to 7 upon 10 and ratio RM upon MQ, corresponding ratio RM upon MQ is equal to 6 upon 8. Now here both this ratio, if it reduce to the lowest form, the second ratio we can reduce to the lowest form. We can write as 3 2s are and 4 2s are 8. So 2 will get cancelled. Ratio will be 3 upon 4. Now if we see the ratio PR upon PQ and RM upon MQ are not equal. If you give the common multiple to any of this ratio, you can divide, the ratio will not be become equal. They won't be become equal. So here, therefore, in this triangle PQR, PR upon PQ is not equal to RM upon MQ. Since the ratio is not equal, the ray PM is not bisector of angle QRP. Therefore, ray PM is not bisector of angle QPR. When it will be bisector, if this ratio is equal, then only it will be bisector by converse of angle bisector theorem, else it is not a bisector of the angle QPR. In triangle PQR, third example, in triangle PQR, PQ is equal to 9, PR is equal to 10, RN is 4 and QM is 3.6. Therefore, in triangle PQR, the ratio PQ upon PR, PQ 9 upon PR is 10, so 9 upon 10, and the ratio QM upon MR, ratio QM upon MR is equal to 3.6 upon 4. Now, is this ratio equal? No. So, here you have to make the ratio equal. If the ratio is equal, then the ray PM will be the bisector of angle QPR. So, if we give the common multiple for this ratio 3.6 upon 4, common multiple will give here 2.5, multiply the ratio by 2.5, both numerator and denominator by 2.5, you will get here, answer will be here 9.00 upon 10.0. That is, the ratio will be 9 upon 10. Ratio will be 9 upon 10. So here, therefore, here PQ upon PR will be equal to QM upon MR. Since ratio is equal, therefore, by converse of angle bisector theorem, by converse of angle bisector theorem, ray PM is bisector, ray PM is bisector of angle QPR. Second example, in triangle PQR, PM is equal to 15, PQ is equal to 25, PR is equal to 20 and NR is equal to 8. We have to state whether this NM is parallel to RQ. Now, let us consider in triangle PQR, this PQ is equal to, in triangle PQR, PQ is equal to PM plus NQ, PM plus NQ, here P dash M dash Q. So PQ is given, PM is given, we have to find NQ. So 25, therefore 25 is equal to PM is 15 plus NQ. So NQ is equal to 25 minus 15, which is equal to 10. Now, here PR is given, we have to find PN and NR is 8. So again the betweenness, PR is equal to, also PR is equal to PN plus NR, P dash N dash R. PR is 20, so 20 is equal to PN plus NR is 8. So PN is equal to 20 minus 8, which is equal to 12. So PN is equal to 12. Now we have to prove whether this NM is parallel to RQ. So if the ratio, the corresponding ratio is in proportion, that is equal, then the line will be parallel by BPT. By converse of BPT, line will be parallel. So let us see in triangle PQR. In triangle PQR, Pn upon Nr. Pn upon Nr is equal to, that is 12 upon 8, 12 upon 8, which is equal to, reducing to the lowest form, here 4 3s are and 4 2s are 8. So ratio will be equal to 3 upon 2, 4 will get cancelled from both numerator and denominator. Same manner now, Pm upon Mq. Pm upon Nq is equal to Pm, that is 15 upon Nq 10. Here 5 3s are 15, 5 2s are 10, 5 will get cancelled, ratio will be 3 upon 2. So here now the Pn upon, therefore Pn upon Nr is equal to Pm upon Nq. Both the ratios are equal. Since in triangle PQR the ratio corresponding sides are in proportion, that is equal, therefore by converse of basic proportionality theorem, converse tells that if ratio is equal, then the line, this line NM is parallel to RQ. Line NM is parallel to side RQ. Third example, in triangle MNP, NQ is the bisector of angle N. If MN is equal to 5, PN is equal to 7, NQ is equal to 2.5, you have to find QP. So as ray NQ is the bisector of angle N, therefore by angle bisector theorem, angle bisector theorem, NM upon NP, NM upon NP is equal to MQ upon QP. MQ upon QP. Substituting the value here, Mn, that is Nm is equal to 5 upon 7 is equal to MQ 2.5 upon QP. Here 5 into QP is equal to 2.5 into 7. QP is equal to 2.5 into 7 upon 5. 5 ones are 0.5. 5 0.5s are. QP is equal to 0.5 into 5 is 3.5 units. Fourth example, measures of some angles in the figure are given. We have to prove that AP upon PB is equal to AQ upon QC. Now in this triangle ABC, angle APQ is equal to angle ABC is equal to angle ABC is equal to 60 degree, which is given in the figure. Now if we will observe these two angles, okay, these two angles are corresponding angles. So by corresponding angle test, these are the corresponding angle. If you see here, and if you consider AB as a transversal, then these two are corresponding angles. So therefore, by corresponding angle test, this line PQ will be parallel to BC. So in triangle ABC, line PQ is parallel to side BC of the triangle. Once a line is parallel to the side of the triangle, then by basic proportionality theorem, therefore by basic proportionality theorem, the corresponding ratio is in the proportion. So AP upon PB is equal to AQ upon QC. That is AP upon PB is equal to AQ upon QC. Fifth example, in trapezium ABCD, side AB is parallel to side PQ and PQ is parallel to DC. AP is equal to 15, PD is equal to 12, QC equal to 14, find DQ. So in trapezium ABCD, line AB is parallel to PQ parallel to DC, which is given. Therefore, by property of three parallel lines and their transversals, AP upon PD is equal to BQ upon QC. So properties here, the corresponding sides are in proportions. So AP upon PD is equal to BQ upon QC. Substituting the value, AP is equal to 15 upon PD is 12. So 15 upon 12 is equal to BQ. We have to find BQ, and QC is 14. Now here multiplying 12 into BQ is equal to 15 into 14. Therefore BQ will be equal to 15 into 14 divided by 12, dividing here 3 4s are 12 and 3 5s are 15, 2 2s are 4 and 2 7s are, that is therefore BQ is equal to 7 5s are 35 upon 2. So 35 divided by 2, dividing you get 7, 2 1s are, 2 7s are 14, 2 5s are 10, 17.5 units will be the length BQ.